Dear viewers, I am your host Muhammad Asif Jaja and you are watching YouTube channel ETV 786 that is specially created for business, commerce and trade students. At initial stage, we are providing you the brief introduction of all subjects that may help you to understand the basic concepts of business. So you are requested to subscribe the channel and press bell icon for instant notification. This is part number 3 of course number 7, that is business statistics. The business courses already delivered on the channel are number 1 accounting, number 2 business management, number 3 business law, number 4 business taxes, number 5 business mathematics, number 6 insurance and its types, and number 7 2 parts of business statistics. Earlier in part 1 of business statistics we have studied definition and importance of statistics in business, data collection techniques and graphical representation of data. In part 2 we have studied measures of central tendency and measures of dispersion. Now, in this session, we are going to study number 1, statistical data analysis that includes covariance, correlation, regression, interpolation and extrapolation, etc. And number 2, index numbers. So let's start the course number 7, business statistics part C. Statistical data analysis. Being a branch of science, statistics incorporates data acquisition, data interpretation, and data validation, and statistical data analysis is the approach of conducting various statistical operations, such as thorough quantitative research that attempts to quantify data and implies some sort of statistical analysis. Here, quantitative data typically includes descriptive data like survey data and observational data. In the context of business applications, it is a very crucial technique for business intelligence organizations that need to operate with large data volumes. Significance of statistical data analysis. Number 1. Data comprises variables which are univariate or multivariate, and extremely relying on the number of variables, the experts execute several statistical techniques. Number 2. If the data has a singular variable, then univariate statistical data analysis can be conducted, including t-tests, that is for significance, z-test, f-test, ANOVA test, that is one way, etc. Number 3. And if the data has many variables, then different multivariate techniques can be performed, such as statistical data analysis or discriminant statistical data analysis, etc. Tools of statistical data analysis. Generally, under statistical data analysis, some form of statistical analysis tools are practiced that a layman can't do without having statistical knowledge. Various software programs are available to perform statistical data analysis. These software includes Statistical Analysis System or SAS, Statistical Package for Social Science or SPSS, StatSoft, and many more. These tools allow extensive data handling capabilities and several statistical analysis methods that could examine a small chunk to very comprehensive data statistics. Components of statistical data analysis. There are two important components of a statistical study. Number 1, population, an assemblage of all elements of interest in a study. And number 2, sample, a subset of the population. Types of statistical data analysis. Number 1, descriptive statistics. Descriptive statistics attempts to illustrate the relationship between variables in a sample or a population and gives a summary in the form of mean, median, and mode. Number 2, inferential statistics. Inferential statistics implies a random sample of data taken from a population to make and explain inferences about the whole population. Probability distribution, correlation testing, and regression analysis fall into this category. Basic 4 steps of statistical data analysis. In order to analyze any problem with the use of statistical data analysis comprises 4 basic steps. Number 1, defining the problem. Number 2, accumulating the data. Number 3, analyzing the data with further include number 1, exploratory methods and B, confirmatory methods. And number 4, reporting the outcomes. Basic 4 steps of statistical data analysis. Number 1, defining the problem. The precise and actuarial definition of the problem is imperative for achieving accurate data concerning it. It becomes extremely difficult to collect data without knowing the exact definition or address of the problem. Basic 4 steps of statistical data analysis. Number 2, accumulating the data. After addressing the specific problem, designing multiple ways in order to accumulate data is an important task under statistical data analysis. Data can be collected from the actual sources or can be obtained by observation and experimental research studies conducted to get new data. Basic 4 step of statistical data analysis. Number 3, analyzing the data. Under statistical data analysis, the analyzing methods are divided into 2 categories. Number A, exploratory method. This method is deployed by determining what the data is revealing by using simple arithmetic and easy drawing graphs or descriptions in order to summarize data. Number B. Confirmatory methods. This method adopts concepts and ideas from probability theory for trying to answer particular problems. Probability is extremely imperative in decision making, as it gives a procedure for estimating, representing, and explaining the possibilities associated with forthcoming events. Basic 4 steps of statistical data analysis. Number 4. Reporting the outcomes. By inferences, an estimate or test that claims to be the characteristics of a population can be derived from a sample. These results could be reported in the form of a table, a graph, or a set of percentages. With the help of statistical data analysis, experts could forecast and anticipate future aspects from data. By understanding the information available and utilizing it effectively may lead to the adequate decision making. Bivariate data analysis. Bivariate analysis is one of the simplest forms of quantitative statistical analysis. It involves the analysis of two variables, often denoted as x and y, for the purpose of determining the empirical relationship between them. Bivariate analysis allows you to study the relationship between two variables and has many practical uses in the real life. It aims to find out whether there exists an association between the variables and what is its strength. Bivariate analysis also allows you to test a hypothesis of association and causality. It also helps you to predict the values of a dependent variable based on the changes of an independent variable. Covariance. Covariance signifies the direction of the linear relationship between the two variables. By direction, we mean if the variables are directly proportional or inversely proportional to each other. Increasing the value of one variable might have a positive or a negative impact on the value of the other variable. The values of covariance can be any number between the two opposite infinities. Also, it's important to mention that covariance only measures how two variables change together, not the dependency of one variable on another one. Calculation of covariance. The value of covariance between two variables is achieved by taking the summation of the product of the differences from the means of the variables as follows. The upper and lower limit for the covariance depends on the variances of the variables involved. These variances in turn can vary with the scaling of the variables. Even a change in the unit of measurement can change the covariance. Thus, covariance is only useful to find the direction of the relationship between two variables and not the magnitude. Plots of covariance. Below are the plots which help us understand how the covariance between two variables would look in different directions. In blue box, covariance of x and y is less than 0, and in green box, covariance of x and y is near to 0, and in red box, covariance of x and y is greater than 0. Example of covariance. Let's suppose x is equal to 10, 12, 14 and 8. Y is equal to 40, 48, 56 and 32. The step number 1. Calculate mean of x and y. When we calculate the mean of x, that will be equal to 11. And when we calculate the mean of y, that will be equal to 44. Then step number 2. Substitute the value in the formula. Let's find xi minus x bar. That will be equal to minus 1, 1, 3 and minus 3. Then we will calculate the yi minus y bar. That will be equal to minus 4, 4, 12 and minus 12. When we will substitute the values in the formula, the covariance of x and y will be equal to 20. Correlation. Correlation analysis is a method of statistical evaluation used to study the strength of a relationship between two numerically measured continuous variables. It not only shows the kind of relation in terms of direction, but also how strong the relationship is. It can assume values from -1 to +1. Correlation coefficient. To determine whether the covariance of the two variables is large or small, we need to assess it relative to the standard deviations of the two variables. To do so, we have to normalize the covariance by dividing it with the product of the standard deviations of the two variables, thus providing a correlation between the two variables. The main result of a correlation is called the correlation coefficient. Properties of correlation coefficient. Number 1. The correlation coefficient is dimensionless metric and its value ranges from -1 to +1. Number 2. The closer it is to +1 or -1, the more closely the two variables are related. Number 3, if there is no relationship at all between the variables, then the correlation coefficient will certainly be 0. However, if it is 0, then we can only say that there is no linear relationship. And number 4, when the correlation coefficient is positive, an increase in one variable also increase the other. When the correlation coefficient is negative, the changes in the two variables are in opposite directions. Example of correlation. Number 1, find the covariance, where x is equal to 10, 12, 14 and 8 and y is equal to 40, 48, 56 and 32. Step number 1, calculate mean of x and y. Mean in this example is calculated as 11 and mean of y is calculated as 44. Then step number 2, find the mean deviation and their squares that will be used to find standard deviation. Here in this example, the mean variation of x is equal to -1, 1, 3 and -3 and mean variation of y is equal to -4, 4, 12 and -12. Step number 3, find the covariance of x and y. Here in this example, the covariance of x and y is equal to 20. Example of correlation. Number 2, find the correlation. Step number 4, find the standard deviation of x and y. To find standard deviation, find n-1, that is 4 minus 1 is equal to 3. Divide the sum of square with n-1, that is 20 divided by 3, which is equal to 6.6. Then find the square root of 6.6, that is equal to 2.58. Therefore, standard deviation of x is equal to 2.58. Find standard deviation of y using the same method, that is equal to 10.33. Step number 5, find the correlation between x and y. Correlation is equal to covariance divided by standard deviation of x multiplied by standard deviation of y. So it is equal to 0.75. Linear regression. Linear regression is a basic and commonly used type of predictive analysis. The overall idea of regression is to examine two things. Number 1, does a set of predictor variables do a good job in predicting an outcome or dependent variable? And number 2, which variables in particular are significant predictors of the outcome variable, and in what way do they indicate by the magnitude and sign of the beta estimates, that is called impact, the outcome variable. These regression estimates are used to explain the relationship between one dependent variable and one or more independent variables. The simplest form of the regression equation with one dependent and one independent variable is defined by the formula y is equal to c plus b into x, where y is equal to estimated dependent variable, c is equal to constant, b is equal to regression coefficient and x is equal to score on the independent variable. Simple linear regression. Linear regression analysis is used to predict the value of a variable based on the value of another variable. The variable you want to predict is called the dependent variable. The variable you are using to predict the other variable's value is called the independent variable. This form of analysis estimates the coefficient of the linear equation involving one or more independent variables that best predict the value of the dependent variable. Linear regression fits a straight line or surface that minimizes the discrepancies between predicted and actual output values. There are simple linear regression calculators that use a least squares method to discover the best fit line for a set of paired data. You then estimate the value of x dependent variable from y independent variable. Linear regression model. In this model, we have presented the data of ads and revenue generated on these ads for a company for a period of 1 year. Types of linear regression. Number 1, linear regression in which a single predictor involved, and other is multiple linear regression where the multiple predictors are involved. Single variable linear regression. In simple linear regression, we try to find the relationship between a single independent variable or input and a corresponding dependent variable or output. This can be expressed in the form of a straight line. The same equation of a line can be rewritten as y is equal to beta 0 plus beta 1 x plus e. Here the y represents the output or dependent variable. Beta 0 and beta 1 are two unknown constants that represent the intercept and coefficient or slope respectively. Single variable linear regression calculator. There are simple linear regression calculators that use a least squares method to discover the best fit line for a set of paired data. You then estimate the value of x dependent variable from y independent variable. Application of single variable linear regression. Number 1, predicting crop yield based on the amount of rainfall. Yield is dependent variable while the amount of rainfall is independent variable. Number 2, marks scored by student based on number of hours studied. Ideally, here marks scored is dependent and number of hours studied is independent variables. Number 3, predicting the salary of a person based on years of experience. Thus, experience becomes the independent variable while salary becomes the dependent variable. Multiple linear regression. In multiple linear regression, we try to find the relationship between two or more independent variables or inputs and the corresponding dependent variable or output. The independent variables can be continuous or categorical. The equation that describes how the predicted values of y is related to p independent variables is called as multiple linear regression equation. Multiple linear regression graph. Here is the graph for multiple linear regression model applied on the IRIS dataset. Application of multiple linear regression. Multiple linear regression analysis can help us in the following ways. Number 1, it helps us predict trends and future values. The multiple linear regression analysis can be used to get point estimates. Number 2, it can be used to forecast the effects or impacts of changes. That is, multiple linear regression analysis can help to understand how much will the dependent variable change when we change the independent variable. Number 3, it can be used to identify the strength of the effect that the independent variables have on a dependent variable. Interpolation. Interpolation is a method of deriving a simple function from the given discrete dataset such that the function passes through the provided data points. This helps to determine the data points in between the given data ones. This method is always needed to compute the value of a function for an intermediate value of the independent function. In short, interpolation is a process of determining the unknown values that lie in between the known data points. It is mostly used to predict the unknown values for any geographical related data points such as noise level, rainfall, elevation, and so on. Interpolation formula. The unknown values on the data points can be found using the linear interpolation formula, which is y is equal to y1 plus x minus x1 divided by x2 minus x1 whole multiplied by y2 minus y1. Interpolation methods. Number 1, linear interpolation method. This method applies a distinct linear polynomial between each pair of data points for curves or within the set of 3 points for surfaces. Number 2, nearest neighbor method. This method inserts the value of an interpolated point to the value of the most adjacent data point. Therefore, this method does not produce any new data points. Number 3, cubic spline interpolation method. This method fits a different cubic polynomial between each pair of data points for curves or between set of 3 points for surfaces. Number 4, shape preservation method. This method is also known as piecewise cubic Hermite interpolation or PCHIP. It preserves the monotonicity and the shape of the data. It is for curves only. Number 5, thin plate spline method. This method consists of smooth surfaces that also extrapolate well. It is for surfaces only. Number 6, biharmonic interpolation method. This method is applied to the surfaces only. Extrapolation. Extrapolation is defined as an estimation of a value based on extending the known series of factors beyond the area that is certainly known. In other words, extrapolation is a method in which the data values are considered as points such as x1, x2, so on to xn. It commonly exists in statistical data very often. If that data is sampled periodically and it approximates the next data point. One such example is when you are driving, you usually extrapolate about road conditions beyond your sight. Extrapolation formula. Let us consider the two endpoints in a linear graph, x1 and y1 and x2 and y2, where the value of the point x is to be extrapolated, and then the extrapolation formula is given as y of x is equal to y1 plus x minus x1 divided by x2 minus x1 whole multiplied by y2 minus y1. Extrapolation graph. As we know, extrapolation is a process of predicting the data point about the outside of a curve when a few points are given. In the example given below, the known data are x1, x2 and x3. Finding the point x4 is known as extrapolation point. Extrapolation example. Question. The two given points that lie on the straight line is 1 and 5 and 4 and 10. Determine the value of y at x is equal to 5 on the straight line using a linear extrapolation method. Solution. Given is x1 is equal to 1, y1 is equal to 5, x2 is equal to 4, y2 is equal to 10. The linear extrapolation formula is given as y of x is equal to y1 plus x minus x1 divided by x2 minus x1 whole multiplied by y2 minus y1. Substitute the known values in the given formula. We will get y of 5 is equal to 11.67. Index numbers. An index number is a number that measures a relative change in a variable or an average relative change in a group of related variables with respect to a base. An index number indicates the level of certain phenomena at some given period in comparison with the level of the same phenomena at some reference period. The index number are usually constructed for economic variables such as price, quantity, wage, unemployment, investment, cost of living, etc. Understanding of index numbers. The value of money does not remain constant over time. It rises or falls and is inversely related to the changes in the price level. A rise in the price level means a fall in the value of money, and a fall in the price level means a rise in the value of money. Thus, changes in the value of money are reflected by the changes in the general level of prices over a period of time. Changes in the general level of prices can be measured by a statistical tool known as index number. Features of index numbers. Index numbers are free from unit of measurement because they show relative changes. For ease of understanding, index numbers are expressed in percentages. To construct index numbers, at least two periods are required, and a period that is economically stable and has no major crisis caused by wars, diseases, strikes, food shortage, etc., known as the normal period, is selected as a base. Uses of index numbers. Number 1. Price rising control. Many economic plans and government policies depend on index numbers. For example, to control raising prices, government import from the other countries or give subsidy or financial support to the manufacturer. Number 2. Forecasting the future economic trends. Index numbers are used to forecast the future economic trends. Number 3. Measuring the oscillation. Cyclic long-term movement, which are in the form of oscillation, and seasonal short-term movement, which are linked with the seasons, are movements which repeat themselves within a fixed period. Movements are measured by index number. Major index numbers. Number 1. Price index numbers. Price index numbers are used to know the purchasing ability of money at different periods and places. Number 2. Quantity index numbers. Quantity index numbers are used to know the changes in the quantities produced, consumed, sold, purchased, import, or exported, etc. Number 3. Consumer price index number. Consumer price index numbers are used to know standards of living of people and to know about the goods and services used by them. Types of index numbers. Number 1. Wholesale price index numbers. The wholesale price index numbers are generally used to measure changes in the value of money. The main problem with these index numbers is that they include only the wholesale prices of raw materials and semi-finished goods and do not take into consideration the retail prices of goods and services generally consumed by the common man. Hence, the wholesale price index numbers do not reflect true and accurate changes in the value of money. Types of index numbers. Number 2. Retail price index numbers. These index numbers are prepared to measure the changes in the value of money on the basis of the retail prices of final consumer goods. The main obscurity with this index number is that the retail price for the same good is not available. The retail prices represents larger and more frequent fluctuations as compared to the wholesale prices. Types of index numbers. Number 3. Cost of living index numbers. These index numbers are constructed with reference to the important goods and services which are consumed by common people. Since the number of these goods and services is very large, only representative items which form the consumption pattern of the people are included. These index numbers are used to measure changes in the cost of living of the general public. Types of index numbers. Number 4. Working class cost of living index numbers. The working class cost of living index numbers aim at measuring changes in the cost of living of workers. These index numbers are consumed on the basis of only those goods and services which are generally consumed by the working class. The price of these goods and index numbers are of great importance to the workers because their wages are adjusted according to these indexes. Types of index numbers. Number 5. Wage index numbers. The purpose of these index numbers is to measure time-to-time changes in money wages. These index numbers, when compared with the working class cost of living index numbers, provide information regarding the changes in the real wages of the workers. Types of index numbers. Number 6. Industrial index numbers. Industrial index numbers are constructed with an objective of measuring changes in the industrial production. The production data of various industries are included in preparing these index numbers. Limitation of index numbers. Base periods must be free from all types of crises caused by wars, diseases, strikes, or food shortage, etc. If such a period is not available, then average of some or all the periods is selected as base. Use of services and commodities by the individuals vary with the locality of people, social customs, standard of living, occupations, ideas of saving, courage of investment, and sources of income, etc. Number 1. Quality of a product cannot be observed at each point. Number 2. Index numbers give rough measure of relative changes. Number 3. Different methods of index numbers usually give different results. And number 4. Prices vary from place to place according to the idea of profit of investors, expenditures on transportation, and awareness about the psychology of buyers. Hence, their collection is difficult. Methods of calculating index numbers. Number 1. Simple index number, and number 2. Weighted index numbers. Simple index numbers again can be constructed either by number 1. Simple aggregate method, or number 2. Simple average of price relatives method. Similarly, weighted index number can be constructed either by number 1. Weighted aggregative method, or number 2. Weighted average of price relatives method. The choice of method depends upon the availability of data, degree of accuracy required, and the purpose of the study. Construction of index numbers. Number 1. Simple aggregative method. In this method, the index number is equal to the sum of prices for the year for which index number is to be found divided by the sum of actual prices for the base year. Construction of index numbers. Number 2. Simple average of price relative methods. In this method, the index number is equal to the sum of price relatives divided by the number of items and is calculated by using the following formula. Construction of index numbers. Number 3. Weighted aggregative methods. In this method, different weights are assigned to the items according to their relative importance. Weights used are the quantity weights. Many formulas have been developed to estimate index numbers on the basis of quantity weights. Some of them are explained below. Weighted aggregative method. Here is the Laspeyres formula. Weighted aggregative method. Here is the Pash's formula. Weighted aggregative method. Here is the Dorbish and Woolley's formula. Weighted aggregative method. Here is the Fisher's ideal formula. Construction of index numbers. Number 4. Weighted average of relatives method. In this method, also different weights are used for the items according to their relative importance. The price index number is found out with the help of the following formula. Thanks for watching the video. Please view, like, share and comment the videos and subscribe the channel to view latest updates. Bye bye till the next show.